So in this lab, we'll be doing an acid-base titration. This is also called a neutralization reaction, and it's called this because we are essentially neutralizing either the acid with the base or the base with the acid. In this case, we are actually titrating an acid of an unknown concentration with a base of a known concentration. So here we have our acid with an unknown concentration, and in order to determine that, we are going based off of this chemical reaction, right? So the lab doesn't specifically say it's HCl, but we are using that as our example. Essentially, it's any monoprotic acid, and HCl is a strong monoprotic acid. That just means we just have one hydrogen, and we are using NaOH as our known, essentially. The overall workflow for this lab, these are like the main steps. We're going to be making a working stock of our NaOH because they provide us with a very strong concentrated NaOH, and we need to make something more dilute than that in order for us to work with. Secondly, we will be prepping to titrate, and then we'll be titrating this unknown acid with an unknown concentration with the NaOH that we make. And we will stop whenever the solution turns pink. So your solution, you will see that it turns a very similar pink to this. This means that we are at our endpoint. At the endpoint, that means the moles of your base are equal to the moles of your acid. So that color change tells you exactly when these moles are equal to each other, meaning we can like backtrack in a way using the fact that we know the concentration of the base. We can go back and concentrate and calculate the concentration of the acid. So that's what we'll be doing after that. So this is just to give you some more detail on what we're actually doing. We are making that working stock. You're going to start off with a very stronger stock of NaOH. You're going to make a dilution using a volumetric flask. And in your procedure on the lab handout, I tell you exactly what volumes to use, but it's up to you to calculate what that concentration is. And essentially all you have to do is use the M1V1 equals M2V2 equation, and that will get you your concentration of the dilution that you make. From there, then you're ready to start setting up for your titration, right? So we are first prepping a solution that we need, and then we actually need to set it all up so that we can do the titration. So your titration is going to look like this. You're going to have something called a burette over our Linmeyer flask containing our acid. And we're actually going to set up 2 trials of this, right? So you're going to have 2 separate flasks containing acid. And the volume and everything is listed on the procedure, and obviously I'm going to have the little video after this to show you. From there, we will be adding our working stock to the burette and have that ready. And we also, this is very important, you can't forget to add indicator to the acid flask. If you don't add indicator, and this happens in person also, like when we do this experiment actually in lab, if students forget to add the indicator, they would just sit there and keep adding base and keep adding base, and they're like, excuse me, why is this not working? And then I'm like, did you add indicator? And you know, sometimes you forget, and all you need is a drop, like an ml, about an ml, and you're pretty much good to go. It's very strong, like it'll show you, it's very sensitive to the pH changes. So as soon as it turns neutral, where the moles are equal, is whenever the color changes from colorless. So whenever you first add the phenolphthalein, it's going to be colorless. And whenever we reach that equivalence point where they're equal, you're going to get a pink color. So yeah, from there is whenever you titrate, keep adding until it's pink. So here I'm showing you, I brought over the starting stock NaOH, and then I brought over a volumetric flask. I'm adding the amount listed on the lab handout, and now I am going to dilute it. So I'm going to push that aside. I'm bringing some water. I need water. So you pull the water on top of the volumetric flask, and then I add the amount that I need to make 100 ml. I'm going to get the water out of the way, moving everything out of the way. Kind of, I forgot what I was doing, obviously. Okay, getting stuff out the way, clearing it out so that I have a lot of space on my workbench. Rename this flask so that you know what it is, and just put it off to the side. That's essentially step number 1. Now we are going to start prepping for the titration. So you're going to bring 2 empty flasks. We're going to rename them Trial 1 and Trial 2. I tried renaming to Unknown Acid Trial 1 and it was too long, the name. So just do Trial 1 and Trial 2. And then we're going to add a certain amount to here. So please look at that lab handout. And then we're going to add. And then I was supposed to add to Trial 2. Anyway, add some phenolphthalein. Just click it and then you'll probably, I added a lot on here. And then I was trying to get rid of the phenolphthalein out of the way and I accidentally removed the acid I was just working with. But it's okay, I still have a bunch of unknown acid left in my original flask. So I'm just transferring to my Trial 2. If that happens to you, it's okay. Just get another flask and add some more. So this time I added about 1 ml of phenolphthalein, which is much better. And notice how this volume changed. So you're going to have recorded the volume before you add phenolphthalein and then after phenolphthalein. This is the volume after phenolphthalein. And then I removed everything out of the way just so I have a bunch of space. Okay, now I'm getting the burette ready and I'm transferring the stock to my burette. You can transfer about 50 ml, that should be more than enough. Now you're going to set up your titration by actually putting the burette, and now you see how it's that similar setup to that diagram we had. Now the burette, the way it works is this stopcock, you open it up so that it lets out a certain volume. And because it has these graduated measurements on it, you can let out a little bit at a time. Now in this case, I'm starting off with 1 ml and then 0.5 and then 0.25. You are going to have to do this. You're probably going to have to throw in an extra trial at the beginning, as just one, so that you have kind of a base idea of how everything works. And it's okay if you messed that one up. If you mess that one up and you put too much, you're going to have extra acid left over in order to do your actual 2 trials. So you're going to have to first add a little bit, and first you start off with a bigger volume, like 1 ml, and then slow down, change it to 0.5, add some. If you feel like it's going too slow, or you feel like you're reaching the end point, like you're scared it might happen soon, then just go slower, go 0.25. It's okay if it takes long. On the next trial, you'll kind of have an idea, right, of how much volume it took to reach to that end point. And that's how you kind of gauge, okay, should I add this much just yet? Like, should I keep adding in 1 ml increments? No, because I know the end point is coming soon, so I'm going to add in 0.25 ml increments, and so on. Now, at the bottom of this lab, there's a little space where you can enter the molarity that you calculate. So if you do everything at once and you take all your data and you calculate everything, you should be able to input that concentration and check whether it was right. If you reload the page, it might be different because it puts a new concentration every time. So just keep that in mind. You can check yourself. If you don't end up checking yourself, it's okay. As long as your data adds up and it shows me that you actually did every step, then I'm good with that. So again, as far as your data, your first step is to make that working stock. So your first piece of data to essentially collect is to calculate what that concentration is using the information you have. Next, you will be recording data based off of the procedure. So just keep that table in mind whenever you're going about your procedure. You're going to have to record some volumes. And then finally, you're going to have some calculated data where you calculate the molarity of HCl. Now, this table, you can use it as a guide. So go in order. First, calculate the moles of NaOH, and next is the moles of, first the volume of NaOH that you consumed, and next the moles, and then the moles of HCl, and then you can divide it out, get the molarity. And then finally, you will be essentially just doing this entire process again without actually having to do the titration on Virtual Lab. So I gave you a problem where I give you the volume that was consumed to titrate a base with an unknown concentration, and you have to essentially do the same thing you did here. If you need some help in terms of how to calculate this, go back to the video from chapter 4 that has to do with acids, bases, titrations, and neutralization reactions. In that video, I show you an example of how to calculate this.